So we want to be able to say something about critical numbers in general, right? We happen to find in the closed interval method that they may be absolute extreme values, but they don't necessarily need to be, okay? And so to begin, let's look at what the mean value theorem says. So we may remember that if we have the first derivative as positive, we have the function as increasing as on that interval, and if it's negative, it's decreasing on that interval, and we can actually prove this using the mean value theorem. So this could appear on a test. It's kind of a nice little short proof that is kind of accessible. So if we looked at just part A, and I'm not going to do part B for the proof, but for part A, well, we know that f prime of x is equal or is greater than 0, right? That's a given. Okay, so then what does that mean? So according to the mean value theorem, we would say, this is f of x2 minus f of x1 over x2 minus x1, and this would be greater than 0. And I'll just say, imagine we were on the interval x1 to x2. Okay, so we're on that interval. Well, if this is true by the mean value theorem, okay, then what does that mean? Well, it means that f of x2 minus f of x1 is greater than 0, because this would, you can multiply both sides by 0, okay? And if it was happened to be, or sorry, by x2 minus x1, if it happened to be negative, the sign would switch and it would work out in the end anyway. But nevertheless, if we isolate this out, f of x2 is bigger than f of x1, and so this just means, by definition rather, that f is increasing, okay, on x2 or x1 to x2, okay, and so b is going to be similar, okay. So neat little short proof, okay, but what does that mean for us? Let's put that into application. Well, we want to find where it's increasing and decreasing, and so all we have to do is, according to that increasing decreasing test, find the spots where the first derivative is positive and where it's negative, and it will be increasing and decreasing respectively. Okay, well, okay, so I need to look at the derivative, right? Let's see, so this is going to be, nope, try that again. 6x squared minus 6x minus 12, right? But I want to figure out where it's positive and negative. Well, wouldn't it be easier just to look at where it is 0? So find where you have critical numbers and remove those. So it'd be x squared minus x minus 2 is equal to 0, and then we can factor this x minus 2, x plus 1 is equal to 0. So that means we have the critical numbers of 2 and negative 1. And so these act as boundaries for the increasing and decreasing interval. Okay. And now it says, by making a sign chart for f and f prime. How I make a sign chart is that I imagine putting the derivative in kind of the top part of the chart and then the function in the lower part of the chart. And I'm going to list my critical numbers on there because I know at those places that's where the derivative is 0, and well, hopefully changes, or it may change sign at these particular places. Okay, and now what I'm going to do is, from each interval, I'm going to take a sample value. So I'm going to look at, in the first interval, maybe like f prime of minus 2. In the second interval, I'm going to look at f prime of 0, and then I'm going to look at f prime of 3 in the last interval. Okay, and what I want to know is, in each of these regions, using that test point, do I get a positive or negative value? Okay, if I put in negative 2 into the derivative, which is right here, I believe I get a positive value, so it's bigger than 0, so that means that the first derivative is increasing here, and consequently the function on that interval is increasing. Okay. Next, f prime of 0, well, if I put in f prime of 0, that just gives me minus 12, which is negative, and so I get something that's negative in this region, or the first derivative is negative in that region, meaning the function is decreasing in that interval. And lastly, f prime of 3, this is going to be bigger than 0, so you have the sign of the derivative in that region is positive, meaning that the function is increasing. Okay, so then I guess the overall problem is asking, where's the function increasing and decreasing? Well, that we have to respond and just say f is increasing on minus infinity to -1, and you can, people do this different ways. I just make a list of intervals. Some people union them together. It's not wrong either way. And then we would just have to say f is decreasing on -1 to 2. Notice that the intervals are always open. When we talk about increasing, decreasing, we always have to have an open interval because we can't say it is increasing or decreasing at a single point. But nevertheless, all of this sign chart and critical numbers talk, this leads into what we know as the first derivative test. Okay, so what this allows us to do is kind of formalize what we saw in the last example. And we say that if we look and find the critical numbers, if f prime changes from positive to negative at c, it has a local max. So all that means here is that it changes from positive to negative, right? So that means we have a local max at x is equal to -1. And you can almost visualize this, right? If you were to just kind of continue this up and then go down there, you would see that, yeah, it makes sense that there's a local max. If f changes from negative, or f prime changes from negative, let's just say negative to positive, I'm sorry, negative to positive at c, it has a local min. Okay, and so here we have that change from a negative to a positive, and you can kind of see it in the graph, and so here we would just have a local min at x is equal to 2. Okay, I would actually need to find, I would need to, substitute 2 and -1 in to the function to find the value, so I should do that. And then lastly, if f prime does not change sign, then it has a saddle point. So what that third case would look like is if we have a sign chart where it's, here's your critical number, and f prime and f, we have, minus, 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 and so it just like decreases and then it stops and then it continues decreasing. Okay, so you can sort of see that behavior, or you could also, have a sign chart where you have, increasing, or positive, 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 and so you have increasing, stop, and then increasing again. Okay, so just be aware of that third case. But then just to recap the other pictures, for a maximum, what you're going to see in your sign chart at C is that you're going to have positive to negative, and so you very clearly get that hill going on. And then in the second case, for the minimum in your sign chart, you would have at C a negative to a positive. So you have down to up. Okay, and so here I'm not going to go through that because I went through that earlier, but we ended up classifying this same thing as up here. We ended up classifying -1 as a local max because it changed from positive to negative, and 2 as a local min because it changed from negative to positive.